On 7A, we are looking at ionic compounds or salts to determine if they are acidic, basic, or neutral. When we are doing that, we're thinking of these salts as the product of a neutralization reaction between an acid and a base. One of our products is water, but the other is an ionic salt with a cation that came from our base and an anion that came from our acid. By thinking about what those acids or bases are, we determine, is the salt itself acidic, basic, or neutral? The first example is KClO. I was able to conclude that it is basic based upon the idea that K, the cation, would have been a part of a strong base. ClO, the anion, would have been a part of HClO. There's two ways to think about this. One works for multiple choice and quick answers, but is not the explanation. It is whichever thing is stronger, quote unquote, wins. Since the KOH was a strong base, it's basic. The real reason behind this, though, is remembering our equilibrium definitions, our definitions of strength, and the reversibility of those reactions. KOH is strong. So when it's in a solution by itself or when it's in water, it ionizes and does not come back together significantly. That means the conjugate of that strong base, the K, is negligible in its strength or does not act as an acid at all. But the conjugate base of my weak acid is a weak base. So that ClO minus ion, when it dissolves into water, can act as a weak base. So here we have the reaction that proves it. Supporting our prediction with this appropriate reaction is super important. It's become a big thing in terms of not just questions about acids or bases, but connecting it to reactions, ionic compounds, net ionic equations, even electrochemistry. So when I think about that, it is the hypochlorite ion that is the conjugate base of a weak acid. So it acts as a base, which means the water that it's floating around in, it accepts a hydrogen from that water, turning back into, in an equilibrium, the conjugate acid or that original weak acid, and in doing so produces the hydroxide ion. Being able to support with the reaction, recognize the reaction, multiple choice, free response, very important. The second one is neutral because we're thinking about, well, calcium's in our family of strong bases. Perchlorate is in our family of strong acids. When they react, we get water and obviously the calcium perchlorate, but that calcium ion came from a strong base, so it can't go back. It is negligible, like the potassium. But this time, the perchlorate ion is also super, or negligible in terms of its weakness to turn back into the original acid. So they are so weak, they don't do any reaction with water. The last one here, ammonium nitrate. Well, that cation came from a base. The base it came from was a weak base, ammonia. Nitrate came from nitric acid. Nitric acid is strong. So short answer, acid stronger than base, so it's acidic. The proof or explanation for that is the ammonium ion is the weak conjugate acid of a base. It donates its hydrogen to a water. It turns back into, in small amounts, in equilibrium, the ammonia ion, and in doing so makes hydronium. And by making hydronium in water, it slightly raises the pH. So we are looking at the acids and bases. We have to be really familiar with these reactions, and they'll come into play as we do titrations, as we think about buffers, and as we do calculations with Ka and Kp.